Ever wondered why you have some of the weirdest traits? Why do we get goosebumps when we're cold or frightened? What's the deal with hiccups? These seemingly insignificant quirks are actually echoes of our evolutionary past, remnants of traits that once served a purpose in our survival. Join me as we journey through the fascinating world of human evolution to uncover the reasons behind these peculiar characteristics. Stay tuned to discover how evolution has shaped these peculiar characteristics. In the face of cold or imminent danger, our skin erupts in a carpet of tiny bumps, a phenomenon we call goosebumps. This reaction is not just a random occurrence but a deeply ingrained response that has been passed down through generations. This seemingly insignificant reaction is a legacy of our hairier ancestors. Back in the days when early humans were covered in thick body hair, this reflex had a much more significant role. Imagine a time when humans covered in thick fur roamed the savannah. These early humans faced numerous threats from the environment and predators. Their bodies had to adapt in various ways to ensure survival. When threatened or exposed to the cold, tiny muscles at the base of each hair would contract, causing their fur to stand on end. This was an automatic response, triggered by the nervous system. This served two crucial purposes. Firstly, it provided a layer of insulation. By trapping air between the hairs, it helped to retain body heat, keeping the early humans warm in cold conditions. The raised fur would trap a layer of air, providing insulation against the cold. This was essential for survival, especially during harsh weather conditions when maintaining body heat was crucial. Furthermore, the increased volume of their silhouette would make them appear larger and more intimidating to potential predators. This could deter predators from attacking, giving early humans a better chance of survival. Today, with our significantly reduced body hair, goosebumps serve little practical purpose. In modern humans, this reflex is more of a vestigial trait, a remnant of our evolutionary past, yet this primal reflex remains, a fascinating reminder of our evolutionary journey. It connects us to our ancestors, showing how far we've come and how much we've evolved over millions of years. Even though we no longer rely on this reflex for survival, it serves as a testament to the incredible adaptability and resilience of the human species. Nestled within the depths of our digestive system lies a small, seemingly insignificant organ, the appendix. This tiny, tube-like structure attached to the cecum has puzzled scientists and doctors for centuries. Despite its small size, the appendix has been the subject of much debate and research. Often considered a vestigial organ, a remnant of our evolutionary past, the appendix has long been a source of biological curiosity. In the 19th century, Charles Darwin himself speculated that the appendix was a leftover from a time when our ancestors had a much different diet. Millions of years ago, our herbivorous ancestors relied heavily on plant matter for sustenance. Their diet, rich in tough, fibrous plants, required a digestive system capable of breaking down cellulose, a complex carbohydrate found in plant cell walls. Their diet, rich in cellulose, required a specialized digestive system to break down this tough plant fiber. The appendix in these ancestors played a crucial role in housing bacteria capable of digesting cellulose, aiding in the breakdown and absorption of nutrients from their plant-based diet. The appendix in these ancestors played a crucial role in housing bacteria capable of digesting cellulose. These bacteria were essential for breaking down the plant material, allowing our ancestors to extract the necessary nutrients for survival. As our dietary habits evolved, incorporating more easily digestible foods, the appendix's role diminished. With the advent of cooking and the inclusion of meat and other nutrient-rich foods, the need for a specialized organ to break down cellulose decreased. Today, while not directly involved in cellulose digestion, recent research suggests the appendix may still play a role in maintaining gut health, serving as a reservoir for beneficial bacteria. These bacteria can help repopulate the gut after an illness or antibiotic treatment, ensuring a healthy balance of gut flora. This new understanding of the appendix highlights its potential importance in our overall health, challenging the long-held belief that it is merely a vestigial organ. The emergence of wisdom teeth, often a painful and unwelcome event in our late teens or early 20s, is another intriguing quirk of our evolutionary past. These third molars, so called for their late arrival, speak volumes about the dietary habits of our ancestors. Our ancient predecessors, with their largely plant-based diets, possessed larger jaws and more robust teeth, essential for grinding down tough, fibrous foods. Wisdom teeth in this context played a vital role in ensuring efficient chewing and nutrient extraction. Over millennia, as our diets shifted to include softer, cooked foods, our jaws gradually reduced in size. Consequently, the space available for wisdom teeth diminished, often leading to impaction, discomfort, and the need for extraction. The sudden, involuntary spasms of the diaphragm that characterize hiccups are not only annoying but also a fascinating link to our amphibian ancestors. Millions of years ago, our aquatic predecessors relied on gills for respiration in their watery realm. The neural pathways responsible for controlling gill movement are believed to be the precursors to the hiccup reflex we experience today. As these early creatures transitioned to land, their breathing mechanisms evolved, with lungs taking center stage. Yet, the ancient neural circuitry persisted, albeit in a modified form. Hiccups, in essence, are a remnant of this evolutionary transition, a fleeting reminder of our aquatic past. Observe a newborn infant, and you'll witness a remarkable instinct: the Palmar grasp reflex. This reflex is one of the first signs of life, a tiny yet powerful demonstration of the newborn's inherent capabilities. It's fascinating to see how, even in their first moments outside the womb, babies exhibit such a strong and instinctive behavior. This reflex is not just a random action, it has deep evolutionary roots and significant implications for the baby's development and bonding with caregivers. Stroke the palm of their tiny hand, and their fingers will curl around your finger with surprising strength. This action is not only adorable but also serves a purpose. The strength of this grip can be quite astonishing, considering the baby's size and age. It's a reflex that reassures parents and caregivers, creating an immediate and tangible connection. This simple act of gripping can foster a sense of security and attachment, crucial for the infant's emotional and psychological development. This powerful reflex is a legacy of our primate ancestry, a time when infants relied on their grip for survival. In the wild, a strong grip was essential for a baby primate to cling to its mother as she moved through the trees. This instinctual behavior ensured that the infant remained safe and close to its source of nourishment and protection. The Palmar grasp reflex is a fascinating example of how evolutionary traits can persist long after their original purpose has diminished. Imagine a primate infant clinging to its mother's fur as she navigates the dense forest canopy. The infant's survival depended on its ability to hold on tightly, avoiding falls and staying close to its mother. This gripping reflex was a matter of life and death, a critical adaptation for survival in a challenging environment. The dense forest canopy provided both opportunities and dangers, and the ability to cling securely was a vital skill for young primates. This firm grasp was essential for their safety and well-being. It allowed the infant to stay with its mother, ensuring it received the necessary care and protection. The bond between mother and infant was strengthened through this physical connection, which was crucial for the infant's development and survival. The Palmar grasp reflex is a beautiful reminder of the deep connections and dependencies that exist in the natural world. While human infants no longer require this level of clinging, the Palmar grasp reflex persists, a testament to our arboreal origins. In modern times, this reflex may seem like a charming quirk, but it is a profound link to our evolutionary past. It serves as a reminder of the journey our species has taken, from tree-dwelling primates to the complex beings we are today. The persistence of this reflex highlights the continuity of life and the enduring influence of our evolutionary history. It's a poignant reminder that even in our modern world, traces of our evolutionary journey are etched into our very being. The Palmar grasp reflex is more than just a cute baby behavior. It is a living piece of our history, a small but significant thread that connects us to our ancestors. As we marvel at the strength and instinct of a newborn's grip, we are also acknowledging the incredible journey of evolution that has shaped who we are today. From Goosebumps to Hiccups, these seemingly insignificant traits are windows into our evolutionary past, reminding us of the incredible journey that has shaped our species. Each quirk, each reflex, tells a story of adaptation and survival, a testament to the power of natural selection. If you've enjoyed this exploration into the fascinating world of human evolution, be sure to like, comment, and subscribe for more captivating insights into the wonders of the natural world. Next time you experience one of these weird traits, remember it's just evolution's way of reminding you of your incredible journey.